Hello everyone, welcome back to our channel. In this lecture series, we are going to discuss about the Computer Communication Network 21EC53 Module 3 Question Bank and Answer Tips. Come, let's go into the video. Please do like, share, subscribe and comment. Moving on to the first question, outline the fragmentation concept in datagram with a size of 4000 bytes fragmented into 3 fragments with need diagram. So this fragmentation concept we have seen in IPv4 and V6. So we will be using the maximum transfer unit for this, and each of the data in terms of bytes that has been sent will be fragmented into different parts. So here you have 4000 bytes which has been fragmented into 3 parts. So 0000 to 1399. So that offset can be calculated by divided by 8. So the starting address value divided by 8 will give you the offset number 1, and this starting value divided by 8 will give you the another offset and the third offset. So this is how it is being done, and here you can see that the data how it is being transferred. So here F1, F2, F3, 3 bytes of data that is divided, the 3 fragmentation is done, and now here the fragmented is again fragmented into different parts and reassembled at the server. So this diagram with this calculation we have to write it in detail, which carries 10 marks. And then moving on to the next question, explain the addressing space allocation in IPv6 addressing. So these are the 3 addressing types that is being used: unicast, multicast and anycast. Unicast is nothing but one client connected to one server. Multicast is nothing but one client connected to multiple servers. Anycast is many number of client connected to many number of servers. And this is the address space allocation. You have 16 bytes of data that has been allocated for the addresses, and this is in decimal notation. You have different notation, slash notation, hexadecimal, daughter notation, all those. So we are using this notation to represent the address space in IPv6. So with this you can completely detailedly explain the answer. Explain the global unicast addressing and special addressing in IPv6. So special addressing is nothing but you have unicast, multicast, anycast, global cast, all these are there, and here is the global unicast addressing, where you can see there is a prefix value 001 will be your prefix value, and the global routing prefix will be routed, and then there is a subnet ID and interface ID. In interface ID is nothing but it is a term called port number. Instead of port number we use interface ID. So each of the IDs will carry m number of bits to 128 minus n minus m bytes bits of data. So you have to draw this diagram and explain what is 001, what is global routing prefix, subnet ID, interface ID in detail, which will carry 10 marks. And moving on to the next question, illustrate the security of IPv4 datagrams. So these are the securities that you can see, that packet sniffing, packet modification, IP spoofing and IPsec. So these are the things that is happening, so that you have to provide security for the datagrams that has been transmitted from one end to the other end. So here packet sniffing is nothing but the packet that has been sent from one end to the another end is the data is being it has been carried out, that is there is no modification happening, but it will be stealed by the nth person. Packet modification is the packet information will be completely modified. And IP spoofing and IPsec is nothing but IPsec is you are providing some IP security. IP spoofing is again it is a threatening thing that one can observe the complete thing and modify the data, but we may not know the data is being modified. And in IP security you have these these four algorithms that is being followed. You have to define algorithm and keys, different algorithms and keys has to be ensured so that the security is maintained. Encryption must be enforced between the client and the server. Data integrity has to be maintained such that there is no modification of data. And origin authentication, only after authentication the required person may enter into an website like bank servers. Yes, so this is the security of IPv4 datagrams. Explain path vector routing with one example. So path vector routing is nothing but you have a network graph here where A spanning tree, each node spanning tree must be found. So A spanning tree, so A to reach E, what all path can it follow, and it should be the least cost path. So for each of the node you will draw this, and then to find one particular new path for one particular node. So here they have taken new C. So for path C, they are going to find out the new path. So what is the old C plus B? Either B you have to take, or with E you can take. It is of our own comparison. So comparing the both, we are going to develop the new C. So for that, formula is best of C plus B. So old C plus B, you have to summate these both so that it will give you the least and new path, best path. So this is path vector routing, and it can be done for each and every node. Hope you have understood the tips. Please be stay tuned for more information. Thank you.